problem, we are to solve the radical equation shown here. If there's no answer, we write do not exist. And if there is an answer, we write our answers in exact form and round it to the nearest hundredth in a decimal approximation. Whenever I solve a radical equation, one of my first strategies is to get the radical by itself, meaning I want this to be the only thing on the left side of the equation. So I'll accomplish that by subtracting 3 on both sides since there's a 3 being added. So on the left-hand side, because 3 subtract 3 is 0, that simplifies out, and you're left with the square root of 2x plus 1. On the right-hand side, 5 subtract 3 is simply 2. The way to undo the square root is to square. In fact, if there's no number written on a radical, then it's assumed to be a 2. So square root actually has what's called an index of 2. So you're used to always seeing that index if it's, say, cube root or something. But you might not know is that there's always an index there. And if it's square root, it's just a 2. So to undo the square root process, the inverse operator is to square it. And if you square the left-hand side, you have to square the right-hand side as well. These processes cancel each other out, and what's left is whatever was under the radical. And by the way, we call that the radicand. So you literally make no changes to the radicand. Whatever it was, you simply copy it down. It was the square root process and the squaring that undo one another. And on the right hand side we have 2 squared is 4. We subtract 1 on both sides. That simplifies out on the left hand side to give you 0. 1 subtract 1 is 0. And 4 take away 1 is 3. So finally, since the 2 is being multiplied by the x, I will divide it. And 2 divided by 2 is 1. So you can think of this simplifies down to be 1 times x. So we have x is equal to 1.5, or if you want, 3 halves. It did want a approximate decimal form, so I forgot to do that. That is 1.5. So checking it, I would take the original equation, and wherever I see the letter x, I'm going to replace it with 3 halves. So I have 2, and that's being multiplied by x, which I'm saying is 3 halves. And then I have plus 1, and all of that's under the radical, and then I have plus 3, and then I have equal to 5 here. So it turns out, and make my radical a little bigger, you could think of the 2 as 2 over 1 if that helps, to clearly indicate that this 2 is in the numerator, this 2 is in the denominator. So it really is these two things simplify out. 2 divided by 2 is 1, and then multiplying by 3 would give you 3. So since these simplify out, you have nothing left but 3 plus 1, or 4, under the radical. And copying the plus 3 and the equals 5, you can see where this is going. The square root of 4 is 2, so I'm left with 2 plus 3 equals 5, and 2 plus 3 is indeed 5, so you get this true statement. So this equation is true if x is 1.5, or if you want 3 halves. So this problem checks out.